Okay, so I'll be talking about the sky this month between now and our next meeting on July 16. And I'll talk about the summer solstice, that's in a couple days, the constellations at this time of year. We'll visit the solar system, and rather than talk about space missions, I thought I would dispense with that, instead talk about Jupiter and Saturn. They've been in the news lately with some interesting changes that are happening, and since they are now prime time targets for this month and next, it's appropriate that we pay a little attention to what's going on those gas giants. I'll then go into deep space, and we'll finish with a easy citizen science challenge for us all. Okay. Okay, summer solstice. The sun crosses the equator on its trek northward in 2 days. Friday, June 21 at almost noon Eastern Daylight Savings Time. That puts us in the narrowest portion of the hourglass shape. There we go. In this 2019 almanac by Sky and Telescope. As you probably know, it's officially night when the sun is 18 degrees below the horizon. So astrophotographers have the smallest window of the year for taking deep space pictures. In true darkness, around 4 hours is available. But you don't need to wait for total darkness to enjoy observing the night sky. Jupiter, for example, is so bright. You can start observing it as well as double stars and bright clusters during astronomical twilight. So if we include astronomical twilight for observational astronomy, we can add a couple of hours to our window of time. This is the whole sky from southern Ontario at midnight tonight. The Sagittarius arm of our Milky Way is now sweeping across the sky. From Sagittarius through Aquila, Cygnus, all the way up to Cassiopeia. And this yellow plus sign represents the center of our Milky Way, the nucleus. And it's largely, you can see how it's fat. The glow of the Milky Way is largest there, but the actual center is largely hidden by intervening lanes of opaque dust. The spring constellations such as Leo and Virgo are beating a hasty exit to the west, meaning the next 30-day period is your last chance this year to catch the galaxies in the area bounded by Ursa Major and Leo, Virgo, this area here. You'll have a chance still to catch those galaxies. And we'll talk about the summer DSOs rotating into view in a few minutes. As for the sun, we reach aphelion on July 4 at a distance of 152.1 million kilometers. That's 2.5 million greater than the average distance, the astronomical unit, or AU, which is 149.6. So we're as far as we get from the sun in a couple of weeks. And we're just about finished with Solar Cycle 24. A panel of experts assembled by NOAA and NASA concluded that the minimum marking the end of the current cycle will occur sometime between July and this coming September. They say the next peak will occur sometime between 2023 and 2025 with 95 to 130 sunspots, similar to Solar Cycle 24 that peaked with 116 sunspots in April of 2014, right about there. Now there's going to be a total solar eclipse passing through the US and the Niagara region in 2024, right in the middle of that predicted maximum. And that could produce a spectacular solar corona reaching out into space all around the sun, as opposed to just wings stretching out from the equatorial region like many of us saw in 2017 during that eclipse in August. Now, at the OSC solar observing sessions and elsewhere, we can now tell our visitors that we are now at solar minimum. And in order to receive enough solar particles to trigger auroras, we would probably need a large coronal hole to rotate into view facing us. Solar wind can accelerate through a coronal hole. Coronal holes are generally visible during solar minimum, and they're typically at the north and south poles of the sun, but sometimes they will occur in mid-latitudes where magnetic field lines fail to reconnect. And the particles in the corona can jump out into space at twice the typical speed of solar wind. And because coronal holes can last for a couple of months, they can rotate more than once into view, so we have an opportunity to predict loosely whether or not we're going to see some activity based on the coronal holes. Now here's a sequence starting from June the 5th, and you'll notice that we do have holes at the top and bottom, but here we have a finger stretching down, and here's another representation of it in simple graphic form. And now what we'll do is we'll step through this and watch as the sun slowly rotates that finger swept across. Some radiation was felt, was experienced, not necessarily enough for auroras. And finally at June 15, we seem to have another hole starting to develop here. So it is possible to get mid-latitude coronal holes, and if they are large enough, we might get enough in the way of solar radiation, solar wind, to produce some auroras. But that's iffy. We'll just have to wait and see. Okay, as far as the moon is concerned, prime time for observing and astrophotography are the last week of June, when I'll be in Algonquin Park, and the first week of July, when we have a new moon occurring on July 2. There's apogee on the 23rd and perigee on the 5th, no longer connected to either the solar full moon or new moon. Now, speaking of the new moon, there will be a total solar eclipse on the 2nd of July. It'll pass over the Pacific Ocean, northern Chile, and central Argentina. And then 2 weeks later, there will be a partial lunar eclipse over Europe, Africa, Central Asia, and the Indian Ocean. And I'm curious to know if anybody's planning to travel down to South America. We have a few in the room here going to South America, and perhaps a few people online that may have their tickets purchased for this trip. And if you do, here is the center line running through Chile and Argentina. I believe this is where the eclipse lifts off the surface. And if you catch it here, the duration is 2 minutes and about 2.5 minutes. Basically the same duration that we had in 2017 back in August for that eclipse. So you'll have the same duration, especially in this area here. If you are unable to go to South America, you can watch it online. There's a website that you can visit on the day of the eclipse and watch the eclipse through the live streaming. And for us here in Toronto, the totality would begin at, well, that's 20, so take off 4, that's 16, that would be 4 o'clock, 4:30 in the afternoon on July 2, if you want to sit down at your laptop or whatever and watch the eclipse. Now, for observing the moon, as far as the lunar X and V are concerned, not this time. That happens at like noon our time when it's over Europe, so it's their turn, not our turn for the X and V. And for libration, we just finished a significant libration here in the southeast limb. It was tipped our way the last 6 days or so. But it'll happen again in July, the 9th and the 10th. Your chance to catch some of these oval dark craters. And the northeast limb or northwest limb, will be tipped our way at the end of June, June 27th through the 30th. And fortunately, when these two sides of the moon are tipped our way, they're also illuminated. So you have an opportunity to sketch or photograph or just take a good look at sides of the moon that you don't normally get. And the moon, weather permitting, we can watch the moon make some interesting moves between July 12th and the 15th. On the 12th, the moon dances the ring around the rosy with Jupiter and Antares. It then does a do-si-do and jumps to the other side of Jupiter the following night. By July 14, the moon has waltzed about halfway, almost exactly halfway between Jupiter and Saturn. And these three will form a striking line of bright points, virtually in a straight line, virtually equally spaced, stretching 30 degrees across the sky. That should be quite a sight. And the dance ends with the moon picking Saturn as its partner on the 15th, when the two of them are just 1.5 degrees apart on the 15th. Here's our inner solar system as of tonight. And from Earth's perspective, Mercury and Venus lie on opposite sides of the Sun. Mercury is east of the Sun, so it should appear low in the west in the evening, setting soon after the Sun. Now, Mercury will actually reach greatest elongation east of the Sun on June 23, then race between us and the Sun towards inferior conjunction on July 20. And Venus, well, it appears west of the Sun, meaning it is the morning star, up in the east before sunrise. But Venus is racing around the Sun faster than we can catch it, or faster than we can chase it, so Venus will rise closer to the sunrise over the next 40 days. It's getting ever so close to the Sun until it reaches superior conjunction in August. And a line from Earth through Mercury will zip right past Mars, suggesting that those two planets should appear very close together as this period begins, and indeed they do. There we see Mercury and Mars just a degree apart, half an hour after sunset tomorrow. So if you happen to have a good view to the west, you might be able to catch a picture of those two planets close together. 2 weeks later, with Mercury 3 3/4 degrees away from Mars, a thin crescent moon joins them. So here's your July 3 challenge. Find the thin crescent moon. Probably need binoculars. Those of us that were up at the CAO for the spring work party in the first weekend of May, we actually caught that moon in the same less than 2 days old, just a day or something. We managed to catch it with binoculars. It was spectacular. I think when I dropped the binoculars down, I saw it with my eye. I think I did. So it's doable. Let's just hope that we have a good weather that night to give it a try. And here's Venus at 5 a.m. tomorrow morning, just ahead of the encroaching rays of the Sun, which will rise about a half an hour later. And here I show you Venus's orbit to illustrate how far it has moved down from its greatest elongation west back in January. Venus will be increasingly harder to view as it slides closer to the Sun, eventually reaching superior conjunction in August. And I think it takes about a month to get out of the Sun's glare, so sometime in late September, early October, it should start rising as the evening star. Here's the outer solar system, and here we see Earth and the outer solar system planets, as well as Ceres and Pluto, as of tonight. Notice how Ceres, Jupiter, Saturn, and Pluto all lie roughly in the same direction from Earth, opposite from the Sun, and should therefore appear fairly close together in the south around local midnight. And since Jupiter is only 2 weeks past opposition with Earth, it's not surprising that it's just west of the Sun-Earth line. And Saturn will be our next opposition planet, with Earth sliding between it and the Sun on July 3, just about 3 weeks from now. Uranus has emerged from the glare of the Sun and is now rising around 2:40 in the morning and will continue to rise earlier each day as the Earth orbits towards Uranus, and Uranus will be in opposition in late October. And Neptune, did it again. There we go. Neptune, appearing west of Uranus from Earth's perspective, rises an hour and a half ahead of Uranus and will reach opposition in September, early September. So looking south around local midnight, there indeed we see Pluto and Saturn appearing close together east of the meridian. Here we have them. And Jupiter and Ceres lie west of the meridian, having just passed opposition recently. Jupiter 9 days ago and Ceres 11 days ahead of Jupiter. So it appears a little bit further west. A drawback of summertime oppositions for us here in Ontario is how low the planets rise above the horizon. Notice how low Jupiter is when checked against the altitude scale on the meridian, just around 23 degrees up or so. Not very high. That's the downside. And the ice giants, Uranus and Neptune, are rising early in the morning. You'd want to wait a couple of months before you pay them any attention. They're just so low and so far. A little bit later, when we get closer to Uranus, it becomes a nice round circle in your telescope that we can look forward to, but probably not until late summer, early fall. Now, the gas giants Jupiter and Saturn are front and center, if a bit low this summer. And here are a couple of Jupiter-Moon events you might enjoy watching or imaging. Let's see if I can do this way. Here we go. On July 4, Io transits Jupiter with its shadow doing the same, about 90 minutes behind. There it goes. There you see the shadow. The moon and shadow transit runs for more than 2 hours. A good photo op would be around 20 minutes after midnight, which we're getting to pretty soon, when the shadow would still be well within the limb of Jupiter, but Io would be out in space off the limb, somewhere around there. And that would be a good photo op, I would think. And for something completely different, you might like the Peekaboo Ganymede plays with Jupiter on the 7th of July. Here we see Ganymede behind the limb of Jupiter. And it only takes 15 minutes after Ganymede emerges from behind Jupiter that it hides again, this time in the shadow of Jupiter. There it is. It's coming out. It's emerging from behind Jupiter. But keep an eye on it, and it starts to disappear very soon. It slides into the shadow of Jupiter. There it goes. Gone. And I think this one is begging for some time-lapse photography. Yeah, that should be fun. And Saturn is at opposition on July 9. And its rings were at greatest tilt of 27 degrees just 8 months ago. So it's still highly tilted, hiding the South Pole during this year's apparition. When at opposition, Saturn will remain low in the sky due to the shallow path of the ecliptic on our summer nights. Meanwhile, you may have heard or read a few months ago that Saturn's rings are transient and are raining down on the planet and will someday cease to be. But not to worry for us, this will take a few 100 million years. But it is fascinating to think how Jupiter and the other gas giants may have had Saturn-like rings of their own in the past at one time.
New NASA research indicates that Saturn's iconic rings are not only younger than previously thought, but also that these rings are actually disappearing at an extremely fast pace. The research found that the rings are draining away toward the planet as a dusty rain of ice particles. Saturn's rings consist mostly of water ice that ranges in size from microscopic dust to large boulders. Ultraviolet light from the sun and plasma clouds coming from tiny meteoroid strikes charge the icy dust, which then becomes bound to Saturn's magnetic field and pulled into the planet by gravity. This material rains into the planet and begins to disintegrate, allowing it to react chemically with the electrically charged part of Saturn's upper atmosphere, the ionosphere. The ions glow in an infrared light as part of this process if the rain is light, but the emissions dim if the rain is heavy. This was observed using instruments attached to the Keck telescope in Hawaii. The rate of disappearance in this ring rain study has allowed scientists to infer that Saturn's rings formed less than 100 million years ago. This means Saturn wasn't born this way, as the planet is known to be over 4 billion years old. And when the ring rain data is combined with observations made by the Voyager 1 and 2 missions, scientists from NASA Goddard are able to estimate that the rings will be gone in 300 million years. So if this rain doesn't go away, Saturn will be ringless another day.
So here we see a video depicting how those rings would gradually disappear over the next 300 or so million years. And they may eventually be reduced to the barely visible thin string-like rings visiting spacecraft have detected circling Jupiter and Uranus. So maybe 100 or so million years ago, Jupiter and or Uranus had impressive rings too. It's possible. The image of Jupiter on the left is what I call classic textbook. We see dark equatorial belts north and south of the equator, a bright equatorial zone, and a football-shaped great red spot as wide as 3 Earths. On the right, we see the current Jupiter, as imaged by Christopher Ho 3 weeks ago from Cebu City, Philippines. The equatorial zone has darkened considerably, while the south equatorial belt has lost much of its color, becoming more of a white belt. And there are some interesting development in and around the Great Red Spot. The spot itself has become much darker as it morphs from an oval to a circle, while narrowing to maybe 1.5 Earth diameters. And it's time for us presenters to fix our presentations that say it's 3 Earths wide. I had to do that for a presentation last week. Notice the dark stripes surrounding the spot. These lines here. Notice that? And they stretch eastward. And to me, it looks like the Great Red Spot is a pool of mercury sitting in the base of a thermometer. What's going on here? Well, the close-up by Christopher Ho gives us some clues. First of all, we have pieces of the red spot breaking off. These flakes are then slammed by jet streams that race around the red spot and shove that material down to the edge, where another racing jet stream will grab that and send it to the east, which is what we're seeing here. And another jet stream this way will grab more material and send it that way. So it looks as though it's bits of the red spot being dragged out and circling the planet. And here's Clyde Foster's annotations of what's going on at the red spot. And if you can see it here, there is the direction of the equatorial belt jet stream. It slams right into the red spot and circles above it, grabbing whatever flakes, and here's another one peeling off, a little flake there, slamming it down to the bottom here where the remnants of the Great Red Spot flakes are crushed, and then jet streams, here's another one going that way, will grab it, stretch it out. So it's rather dynamic. We're seeing a lot of stuff here, a great amount of turbulence behind this spot. As this spot is changing. Now, it's not really getting faster. That's what a lot of us thought.
Jupiter's appearance is the result of its swirling interior of gases and liquids, producing a tapestry of colorful cloud bands, as well as the iconic Great Red Spot. The Great Red Spot is a gigantic storm. It's an anticyclone, and with no landmass on the planet to slow it down, the Great Red Spot has raged for over a century. But scientists studying the spot have noticed that it has been changing over time. The color is deepening, and it's actually shrinking and getting rounder. Those studying it expect it to therefore see the wind speeds inside the Great Red Spot increasing as the storm shrinks, like an ice skater who spins faster as she pulls in her arms. But this isn't the case. Data reveals the storm isn't spinning faster, it's actually getting taller. You could think of it like working with pottery. As the wide lump of clay spins, forces within are driving it taller. So from our perspective, looking down on the clouds, we see the spot getting smaller and rounder. The Great Red Spot used to be big enough to fit 3 Earths. Now, it's just a little over 1. These discoveries were made by analyzing data from numerous NASA missions, including Voyager, Hubble, and most recently, Juno. And through more investigations, scientists hope to unlock more secrets of the mysterious Great Red Spot.
Whoops. Here's one more image, fascinating image. This was posted by NASA on their picture of the day on June 10 with the description that this darkness, typically dark features are lower and the brighter features are up higher. So it's very possible that this dot, this black eye looking back at you, is actually a deep hole in the clouds, although that is at this moment still conjecture. This picture was taken by the Juno spacecraft when it was 15,000 kilometers above Jupiter's cloud tops, and it's going to make another close pass again in July. So maybe we'll have another look at this eye looking at us. Now, out of this, out into the rest of the solar system, how about meteor showers? Well, there are none at this time. Please check back next month. How about comets? Well, my deepest regrets, but I'm afraid there are no easily observable comets at this time. How about auroras? Well, you know, we're at solar minimum, right? So there are a few sunspots, if any, no CMEs, maybe if a coronal hole is really big, maybe. And if you'd like to keep your hopes up and you want to stay on top of this, there are 2 websites I strongly recommend, spaceweatherwoman.com and auroraforecast.com. You can put those on your favorites and keep an eye on what's going on with the sun, but I wouldn't expect auroras at this time. And the same for lunar and asteroid occultations, were none at this moment. How about asteroids? Well, here we have something. Here are 4 asteroids that will be passing opposition during the next 30 days. The brightest of which is Melpomene. It's number 18 in the list, and it will be as bright as 9.6 on July the 2nd, somewhere around here-ish. Maybe around there, that dot. These others are also reaching opposition, although they're much fainter at magnitude 11 or fainter. And you can go to this website listed at the bottom of the screen here if you would like to visit and learn more about these great charts, very good maps, and so on from that excellent website that I suggest you give it a look. The ISS, we have lots of visible passes. I'm simply showing you 5 of them that are most overhead, the highest ones that reach the greatest altitude. Here's one on the morning of July 16. It's 10 minutes long. It almost looks like it's very, very close to the zenith. It will reach magnitude -3.9. And then later that same evening, it makes another pass, this one lasting 11 minutes. As you may know, heavensabove.com is where you want to go to create your own predictions. Key in your location so it knows where you are, and it'll produce charts like these. As far as lunar transits, there's a great website here, transitfinder.com, and I went there, and the first thing I did was choose the Science Center as the location, which produces these numbers for longitude, latitude, and altitude. I then key in the range to search. That was the biggest range I could grab at that time, and I said I'm prepared to go 80 kilometers, and then I calculate, and this is what I got. A lot of transits of Jupiter across the sun or the moon. I've picked out 4 that I thought might be of interest. This one is kind of interesting because this one here on June 22nd, it's in the daytime. The ISS is crossing in front of the moon, so I'm curious as to what would that be like if the moon is up. The part of it would be lit. Would the ISS be a silhouette as it passes in front, or is it also seeing sunlight? I really don't know what you would get there. But here's one that might catch your fancy. This one is a solar transit on July the 2nd, the same day as the sun eclipse, with CAO smack in the middle of the center line. That's 10 o'clock in the morning on July 2nd. If anybody's up there and wants to give that a try, put your telescope on with a filter on the sun and see if you can get put it in movie mode, because it'll zip right through the sun really quickly. But you might be able to capture some frames of silhouettes from some CAO. And it also, it also passes through the Whitby Oshawa area. And here's one more that goes through Port Perry and so on. Again, transitfinder.com is the website that will generate these charts for you. And for deep sky, here we see this week around 11:30, we have an unusual opportunity to see the spring stuff and the summer stuff. In fact, if I draw a line here, everything to the right I would call memories of springtime, where you still have an opportunity to catch the galaxies that are in this oval area. But on the other side of the line, we have the Milky Way rising and bringing with it a lot of deep space targets of a different nature. We have globular clusters marked by circles with a cross in them. All kinds of globular clusters, because they concentrate around the galaxy's core, which is right about, where's that? Yeah, here's the core of our galaxy. So it's not surprising that we see globular clusters on either side of it, right? And then the Milky Way itself, where it gives birth to stars, that's where you would expect to find globular clusters. And there's a wealth of them right along the arms of the Milky Way, noted with dotted circles. There's also planetary nebulae. Of course, if the majority of stars are along the arm of the Milky Way, that's where you would expect to find other things such as stars passing on. And those would be the planetary nebula that we have, so like here and elsewhere, a few of them. So you have an unusual chance, is the way I like to put it, an unusual opportunity any clear night over the next couple of weeks to look at anything you want. You can go for galaxies, you can go for globular clusters, you can go for planetary nebulae, and you can also go for all kinds of nebulae, such as, here's a slide from my March presentation, where I'm showing you the wealth of galaxies in the Virgo cluster, so you can catch those with anything from a small telescope up to a big, of course the larger the better. But even with a 6-inch or 4-inch telescope, you can catch the Messiers in that group. And here's a beautiful globular cluster that was posted by Sailu Nemena. He took this picture from the Sulor Observatory, the SLO Observatory up at CAO just a few days ago. He posted it on our forum on June 12. That's a fantastic picture. And globulars are my favorite for deep sky. They're so impressive. And the globular clusters here, I'm showing you 9 of them stretched across either side of the center of our Milky Way. There we have a few on this side, a few on that side, Messiers. And on the next slide, here's information as to where they are, their right ascension declination, some notes about them. You can get this by downloading the presentation. It'll be available on our main website within a couple of days, I would imagine. And you can download this and you'll have yourself an observing list to go to work on globular clusters. Open clusters are along that line as well, because it's the Milky Way where stars are born. That's what open clusters are, newly hatched stars. And here we see 6 of them, and on the next slide, information as to where they are. And as far as nebulae goes, you've got a choice here. You've got the dark nebulae, such as the Rift, racing right through the Milky Way. That's the stuff for future stars. As far as current stars that were just born, you'll have emission nebulae, such as M8 and M20 and NGC 7000, the North America nebula. Those are places where new stars have been born, and they're so hot that they cause the gas and dust around them to glow. And then at the end of their lives, we've got a few sun-like stars that have passed on, M27 and M57. So you have all kinds of nebulae representing stars at different phases of their life available for you. And here's a chart showing you their positions and some notes about them. And finally, for Globe at Night, this is a simple exercise that I promise I'm going to do it, and hopefully many of you will do it as well. It's simple, it's easy, and it involves Hercules. This is a project that runs from June 24th to July 3, so during that time frame, go outside and look at Hercules and decide which of these charts represents your sky. How much of Hercules can you see? Is it like this? Is it really poor like that? Are you somewhere where it's very dark and you get to see a lot of stars? So choose which of these pictures represents your sky, and then you go to this website to key in the date and time, click on a map as to where you were observing from, key in some information about your observing site, choose which of those magnitude charts represents your sky, what were the clouds like that day, and description about this, the weather conditions, how was your sky, and then scroll further down and click submit. And I promise to do that. Hopefully many of you will do it as well and participate. And I think that wraps it up. Lots of sources of information. Any questions, please? Ron.
Great visuals. Anyway, I noticed you showed an image of the sun saying that these are the holes, but I don't see that when I look at hydrogen alpha. Is there a particular type of filter that brings that out, or is that something that professionals need to manipulate things for?
You've stumped me.
Okay.
I honestly don't know. Sorry. Who else wants to stump me? Here's your chance. I guess that's it then.
Images are basically ultraviolet images, so, or high ultraviolet images. That's all. So that's the only way you're going to be able to see them.
Thank you for that. All right.
Thank you very much, Arnold, for a great presentation again.